Hello everyone, welcome to Math Alien. Today I'm going to tell you a very famous math problem. It started off with a game. So let's say we have a lot of objects. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 objects here right now. No, it's 10, my bad. There are 10 objects. So every time you can either take one object, two objects, and three objects. It's your move. So you can take either one, two, or three. One, two, or three. Okay. And you're trying to win this. So how are we supposed to do it? So we know that we started off with 10 things, 10 uh 10 objects, and we can take from 1 to 3. How do we make a win though? That's a very nice little question. If you pick any number, for example, like 10, 9, if you go like randomly, uh, the perfect sequence, so you take one, your opponent will probably take one. So under perfect play. So you take one, your opponent takes one. Now you decide to switch things up. You'll take three. So which makes it 5, right? Your opponent takes one. So that's a -3. -1, right? Now you're at a crossroad because if you take 3, for example, that makes it. If you take 3, that makes that's 4. So if you take 3, that makes it 1, and then you take 3, and then he just has to take 1, 0, and he won. So the goal of the game basically is to be the last one who actually the last one to take the last pieces. This is a very famous game. It's called the Subtraction Game. And a lot of people would say, "Oh, it's just a matter of luck. He won because of luck." No, guess what? You could have won the game. But how so? Like, I was wondering, like, how so? Here we can actually discuss it out. So we actually don't have to do 10 and 3. We can actually represent them as different variables. We can first represent the first number as m in total. Let's write it down. Total. And then each time the thing is n. N is the last one. So n is the number of objects. So its last time was 1 or 3. So it's the maximum amount of objects you can take. Max objects. Now, what should we do? Like, we know that this is something. We want to figure out winning positions. So for example, in our previous example, 4 is a winning position. Because no matter if you take 3, he can take 1. If you take 2, he can take 2. And then if you take 1, he can take 3. So 4 is a winning position. Well, guess what? We can actually like conclude this rule together. So n plus 1 is actually a winning position. Since 4 is 3 plus 1, right? Why is n plus 1 a winning position? So let's take a look. If you take n, he has 1. He can take 1. If you take n minus 1, he can take 2. You see the vision, right? You see the vision. If you take 2, he can take n minus 1. If you take 1, we can represent them by dots. And then if you take 1, you can take n. So n plus 1 is a winning position. And we want to achieve something like n plus 1. How are we supposed to do it? Well, there's a very unique way. So as we can see, like for all the numbers like 1, 2, 3, all the way up to n, there's always a pair that adds up to n plus 1, right? So guess what? Every time we just want to make sure it's a multiple of n plus 1. So let's say we start with 10. So if we started with 10, what we want to do right now is we want to make it to 8. We want to make it to. So in the 10-3 example, we know that we have to keep it an n plus 1 at the n plus 1 multiple, which is 4, right? So what multiples of 4 we have? Oh, we have 4 and 8, so we want to go to 8. If we want to go to 8, we would have to take 2, right? Okay, now your opponent is at the crossroad. If your opponent does anything, for example, he plays, let's say he takes 2, so minus 2, 6. What you want to do, remember, force multiple. How would you get force multiple? Minus 2 yourself. So we got like 4 again. Now your opponent is at the crossroad. What can he play? It's a winning position, as we discussed, right? This is the winning position. So no matter what he does, let's say if he does like if you take 1 piece, so -1, we get 0. We won the game. Yeah. So this is basically the winning strategy. So if we're starting with n pieces, we want to make sure we have to subtract a certain number k that makes it a multiple of n plus 1. So in math, we write it as this: n minus k is congruent to 0 mod n plus 1. Mod is the remainder that you get from dividing something. Yeah, this is a nice little formula. For a bigger number, let's say like 114, 514, right? Oh, this is a very big number, and if we're starting, okay, let's say if we're starting off at 3. How do I identify if it's a winning position or not? If it's our move. Guess what? The way to identify if it's a winning position or not is by checking out this number and the relationship with this number. So you add 1, so this is 4, and then see if it's a multiple of 4. How do I identify if 114, 514 is a multiple of 4? I like this nice little trick, 114, 514. You only look at this. Why? Because 100 is a multiple of 4. So 114, 500 is a multiple of 4. Is 14 a multiple of 4? No, it's not. So it's not a multiple of 4, but ends up with an even number. So it's probably a multiple of 2, and you divide it by 4. There must be a remainder of 2. So R2. If it's R2, then we want your opponent to have the multiple. So basically, we just have to minus 2, and then you're basically stuck. So your opponent, if your opponent like let's say minus 1, you actually want a minus 3, because let's put it this way. So if we let your opponent stuck with a number that is a multiple of 4, let's say it's equal to nk, and then your opponent minus a random number. So first of all, k is just a random number, n is the multiple. Okay, let's demonstrate it this way. So we have m and n. N is the total, and m is the number of pieces you take. So the winning sequence is letting our opponent have something called m plus 1 k, right? As we discussed, it must be a multiple. And your opponent subtracts, for example, anything between the range of m. Let's call it a, right? What is a? And then each time you want to make sure you subtract what? M plus 1 minus a. Why do we have to do this? Because m plus 1, let's rewrite this, okay, minus a minus, we leave m plus 1 in the brackets. I want to like to do it. Plus a, because negative, positive. These two convert to positive. Now a cancel out. And then your opponent is left with m plus 1 times k minus 1. Because there's like minus 1 here. So your opponent is also stuck at m plus 1. So if you're at a move, and then if it's your move and you manage to let your opponent get m plus 1k, you just have to repeat the same pattern. So for example, if it's 1, what is m? And then for example, like still back to the 10-3 game. If you manage to get 8, and then you want to pick 3 of them, it's your opponent's turn. If he picks 1, you actually pick 3. If he picks 2, you pick 2. If you pick 3, you pick 1. So the idea basically is to make sure both of them together add to n plus 1 in this position. 3 plus 1 is 4, right? So this is the way to win a game. How do you identify if you're losing? Let's get back to example 114514. 144. How about this? 3. Well, guess what? Same strategy. 44 is a multiple of 4, so mod 4 is 0. So guess what? Now you got the n plus 1k. So if you got the n plus 1k, you're technically losing. Uh, if you're playing against someone, if you say that you go with 3, if he goes with 1, if you go with 2, he goes with 2, and if you go 1, he go 3. It's time for you to resign because he knows the strategy. So so basically, if you like, let's calculate the probability. So in order to win, yours cannot be a multiple of 4. So the chance of it is being 3 over 4, right? And your opponent getting the win is 1 over 4 if you have to choose a number that is a multiple of 4. So guess what? If you have the upper hand, it's more likely for you to win the game. Thank you so much for watching this video. This is a brief video about a very simple topic, but a very interesting math problem. Thank you so much.